On this part of physics, we are going to talk about concave and convex mirrors and concave and convex lenses. So we are talking about mirrors and lenses, whether they are concave or convex. We know that plane mirrors or flat mirrors that we use them in our homes, that they have the same level, they give us images. So flat mirrors, when we put an object here, this mirror, it gives us, when you put object here, it gives us what? Images. And these images, as we know that we're gonna see them here, these images, they are the same size of the object, same distance of the object, upright, that means the head is still up, so upright. And also just the difference is it is laterally inverted. So that means the right hand, you're gonna see it left side, left hand. And also these images are classified as what? Virtual image, not real. So now this one now is for plane mirrors. Okay, what about if the mirrors is not plane? What about if it is concave or convex? Okay, when we are studying plane, when we are studying concave, convex mirrors and lenses, what do we study? Or what do we know we need from studying these ones? What do we need exactly is we need to understand what are the properties of the images that they are produced. What type of images or what are the properties? And then based on understanding what type of properties and images they are produced there, we're gonna understand when to use these lenses and what? And mirrors. So we start now. Here, for example, if I give you this mirror, this is now a shape of a mirror. Is this mirror now concave or convex? How do I know? So it depends on where you are. So if you are here as a person, how are you gonna see this one now? You're gonna see it as a concave. The shape that you will see it from this side is a concave shape. So that means you can be in this shape. You can go to be inside it. So that means this shape is what? Concave. But if you are here, if you are on the other side, how will you see this shape? You're gonna see it a convex shape. That means you can be on this shape, not inside it. So that means concave shapes or convex shapes, it depends on where you are to see convex or concave, where the object is. Okay, but now in physics, we agree that the object can't be on the right of the mirror. So the object always what? On the left of the mirror. So that means based on that means the object here on the left of the mirror. So that means how this object will see the mirror, it's gonna be what? Concave mirror. So this one is what? Concave mirror. It is, remember, as cave, it looks like a cave and it can be inside it. So that means now this is concave mirror. Okay, well now we gotta start understanding concave mirror properties. And when we study concave properties, we are studying the properties of the images that will be produced by concave mirror. Okay, to remember what we mentioned, the image of the plane mirror, the images will be same distance and same properties here, regardless of what's the distance between the mirror and the object. So whether is it close or far away of the mirror, the properties of the image will remain the same. Okay, but does that happen with concave mirrors? No. It depends on how far is the object away from the concave mirror. Okay, just before we study the classifications now and the properties of images, we need to understand now any concave mirror. This is now concave mirror as we agreed, and this is the object on the left of the mirror. This concave mirror, we have to know that this is now part of a circle. It is part of what? Of a circle. So that means if you complete the circle here, as you see, it's gonna be completed as a circle. So now for any circle, there is a radius. There is what? A radius. So now the distance between the mirror to C, it means the radius. It means the radius of what? Of the mirror. And in the middle of this distance, there is a point that is called what? Focal point. And this focal point is the point that the rays are usually, and parallel rays to the principal axis are reflected to this focal point. So that means we have here the mirror, and we have here F, and we have here C. And C always equals what? 2F. So that means 2 times the distance from the mirror to F. So when we say what is the focal point, and when you get to study what is the focal point, what is the F of a mirror, that means we are asking about the distance from the mirror into what? Into the focal point. And to this point, it's going to be twice the distance from the mirror to F. So that means twice of it is going to be the distance between the mirror and the C. So that means when we are studying concave and convex mirrors and lenses, we're going to use center, which is C. We're going to call it either C or 2F. And we're going to use what? F, which is the focal point. And also this line now that is passing from here, we call it what? Principal axis. So for each case, we're gonna make the drawings and understanding based on these ideas. Now we start. So the first case for concave mirror, this is now concave mirror. And as we said, this is now the principal axis. And on the principal axis, we said there is F, and there is what? 2F. There is F, and there is 2F, which is what? C. Now, the first case, if the image or the object, if the object is far away here, that means far away at infinity. The object is far away, that means what? At infinity here. This is the object. Where will be its image? The object is at infinity or far away of the mirror. Where will be its image? Its image will be formed here at F. Its image will be formed at F. It's gonna be very small and we can't see it. We can't what? See it. So this is the first case and you need to memorize it. So you understand now what is the first case of the image for concave mirror. Okay, what is the second case now? The second case here, we're gonna study it. Here, as we see the concave mirror, and this is now the principal. And the principal, as we said, there is F, and there is what? 2F. Now, if the object is at this place, that means beyond what? Beyond the 2F, beyond the center. Where will be its image? Where will be its image? Okay, the image, we're gonna draw it pink. The image will be exactly between the F and the 2F. The F and the 2F. So that means this is the object and this is what? The image. So you need to memorize this point. When the object is beyond the 2F, but it's not at infinity, it's just beyond the 2F. In this case, the image will be between F and the 2F. And the image will be inverted. What does it mean inverted? So that means it is inverted upside down. The head here was up, so here now it becomes what? Down. I hope that is clear. So the image will be between 2F and F, and the image will be inverted, plus the image will be smaller. The image will be what? Smaller. So here we write what? A smaller image. Smaller image than the object. That means when you say smaller or bigger, that means we are comparing the image to the object. So that means compared to the size of the object, we're gonna see the image is what? Is smaller. And also it's gonna be real. It's gonna be what? Real. What do we mean by real? Just link it in your mind. For when we are studying mirrors, not lenses. When we are studying mirrors, remember that if the image and the object are on the same side. So that means, as you see, both of them are on the left side of the mirror. So that means if both of them are on the same side, image and mirror, remember that the image is classified as real image. Is classified as real image if we are talking about mirrors. And real image, it means this image now is real. That means you can project it. You can project this image on a screen, and you can see it. You can see it since it's real. If it is projected on a plane or a wall, you can see it. Okay, now we understand what is the second part or the second case of concave mirror. Okay, what is the third case? This is now the third case. This one is the concave mirror, and as we said here, it's gonna be here F, and here is what? 2F. Now, what would happen if the object is at the 2F? So as you see, we are studying now the object while it is going from left to right towards the mirror. We are studying the cases in order. First it was at infinity, then it was beyond 2F, then now we are studying it when it is on 2F. Then in the next case, we are going to study it when it is between the 2F and the F. Then third case, the next case, we're going to study it when it is on the F. Then the next case, we're going to study it when it is between the F and the mirror itself. So in this case now, if the object is on the 2F, that means on the center, in this case, the image will be also on the 2F, but inverted, and also what? Same size. Same what? Same size here. It's going to be same size. So same size, inverted, and also what? Real. Why real? Because we sit here in the same size, image and object are the same size. So that means it's the same size and also same distance from the mirror, and also inverted and real image. So we understand now the third case. Okay, what about the fourth case? What is the fourth case? Okay, the fourth case now for concave mirror is when the object is where, as we said, we are studying from left to right. So this one here is F, and here, as we said, is what? 2F, which is C, the center. The center, C equals to F. Now, when the object now is between the F and the 2F, so that means the object now is here. The object is between 2F and F. What will happen for the image? Where will be the image? In this case now, the image will be what? Will be beyond the 2F. So look here now. As the object is moving to the right, in these cases, as the object is moving to the right towards the mirror, its image is moving away from the mirror to the left. So that means, as you see, case number 4 is exactly the opposite of case number 2. Is exactly what the opposite of case number 2. So here now, when the object is between 2F and F, as you see, the image is beyond 2F. And in case 2, when the object was beyond 2F, the image was what? Between F and 2F. I hope that is clear now. So what are the properties now of this image now? As it's gonna be here what? Larger. It's gonna be larger. It's gonna be what? Larger. So when the image will be larger, if the object is between F and 2F. So larger, and also inverted, as you see, upside down, and also what? Real image. I hope that is clear. Okay, here now 4 cases. Okay, we go now to the 5th case. Okay, for the 5th case now, this is now the concave mirror, and in the concave mirror here, we have, as we said, we have here F, and you have here what? 2F. Now, in this case now, we're going to study when the object is where, as we said, we're going to study it when it is what? When the object is on the focal point, on F. Where will be its image now? The image will be exactly the opposite of case number 1. So the image will be at infinity, and we can't see it at infinity. So that means now the image will be at infinity. Same thing we said here when the object at what? At infinity. So for case number one, we said when the object at infinity, the image is at f. Now is the opposite. When the object is at f, the images will be what? At infinity and very small and can't be seen here. Okay, now next case. What about this case now? This is now the concave mirror, and as we said here, f and 2f in all the cases. Now what about if the object is here? What about the object is what? Between the mirror and the focal point. Where will be its image? And remember that this is different case. So in this case, if you extend the principal axis, you're gonna see the image on the other side of the mirror. And in this case, it's gonna be, as you see, upright. So not what? Not inverted. So it's upright and also larger. But here it's gonna be what? Virtual image. It's gonna be what? Virtual image. And as we said, why it's virtual, just to put that in mind here, because it's looked in the other side of the what? Of the mirror itself. And what's mean virtual? That means it cannot be projected on screen. Just to link it to your mind, when they are the image for mirrors, when image and object are on the same side of the mirror, the image will be real. But if they are on different sides, like this case now, as you see, the object is on the left side of the mirror and the image is on the right side of the mirror. So in this case, the image is classified what? Virtual. And it is the only case that the image is virtual on the concave mirror. All these cases are related to what? To concave mirrors. And in concave mirror, in all the cases produce real, but in this case it produces what? Virtual image, and upright and larger. So we understand now cases of images and properties of images for what? For concave mirror. Okay, we'll add just here a case which is related to convex mirror, which is for convex mirror. Okay, for convex mirror now, this is how it looks. This is the convex mirror. And we said we put it like this since the object where is on the left. The object is on the left. So here, as we know, will be the F, and here will be what? The 2F. Okay, now on convex mirror, the object is here. Where will be its image? Where will be the image? The image will be here. And convex mirror only it has one case. Again, for concave mirrors here, for concave mirrors, we have case number 1, case number 2, case number 3, case number 4, case number 5, and also case number 6 here. So you have 6 cases for concave mirrors. And in convex mirrors, we have only one case. So in convex mirrors, we don't care about how far is the object from the mirror. Whether is it close to the mirror or away, the result is one result. What is the result? The object will be between the F and the mirror, and as you see, it's gonna be what? Smaller, and also what? Upright, and also what? We said what? It's gonna be virtual. And you understand how we classify it here virtual since it is on the other side of the mirror. So you understand now cases for convex and concave mirrors. And this one is very important to memorize them. And if you memorize them, many questions will be easy for you. Many questions will be easy for you. Just to give you one type of question. If the question is talking about concave mirror, and the question tells you now the object is 30 centimeters away from the mirror, and they tell you the focal point the focal point is 10 centimeters. Now, the question will be about the image. The question will be about the image. Well, the image, what are the properties of the image? Just what are the properties of the image? So the question now, again, is about concave mirror. If the object is 30 centimeters away from the mirror, and the focal point of the mirror is 10 centimeters, what are the properties of the image? Okay, now, to understand it, you need just to go as fast as possible to sketch this question. So that means now they are talking about the concave mirror. This is a concave mirror. And the concave mirror, we have F and 2F. And here the F is 10 centimeters. So that means this one is what? 10 centimeters, which is what? F. That means 2F, which is twice the F is going to be here at what? At 20. Now, where is the object? The object is 30 centimeters. That means the object is where? The object is here. You see? This is the object. So that means the object is beyond the 2F, is beyond the 2F. So that means they are talking about which case? They are talking about this case, you see? So that means here now they are talking mainly about what? This case, when the object is beyond the 2F. Now, what are the properties of the image? You memorize it. It's gonna be between the 2F and the F. Number one, it's gonna be smaller, inverted, and also what? Real. Is that clear? Okay, now we understand the properties. So when the question comes and you remember these properties, it's easy for you to answer the question. Plus, you can also predict the number. Okay, now the question is, the image, where will be the distance of the image? Will it be, for example, here, 12 centimeters, or it will be 30 or 25? Which one are you going to choose? Where will be the location of image? Will it be 12 centimeters or 30 centimeters or 25 centimeters? And when we are talking about distance, we are talking about the distance from the mirror to the image. As we said, based on the properties of case number 2 now, this one is case number 2. And in case number 2, it says that the image will be between the F and the 2F. And now, when the image is between the F and the 2F, that means it's going to be in this place. And in this place, that means it's going to be between the 20 and the 10. So you go to choose the number that is between the 20 and the 10. I just gave random numbers here. I gave you random numbers just to predict. How can you predict the numbers that could be what? Right? Based on memorizing what? The cases. Okay, these cases now are, as we said, for concave and convex mirrors, not lenses. Okay, one more idea to understand. So we understand now all the cases of convex, all the cases, it's only one case, and always it produce what? Virtual image. So convex mirror, always it gives you virtual images, while concave mirror, it gives us most of the time real images, but on one case only it gives us what? Virtual image, which is case number 6. And now also you need to understand the concave mirror, it is classified as convergent mirror. What's mean convergent mirror? That means it converges the light. If the light is coming to it like this, it converged. That means it converged. That means it collects the light towards a point. It collects the light into what? Into a point. So that means it is classified as convergent mirror. While convex, it diverges. So that means it is classified as divergent what? Mirror. It diverges the light that, or the light rays that it received by it. Okay, now we finished the cases of concave and convex mirrors. Okay, what about if we are talking about now lenses? Lenses now cases. Okay, what are the cases of lenses? Okay, just I needed to memorize that. Related to lenses here, this is the lens. This is now a lens. So the lens, this is now convex lens. This is now convex lens. While this one is what? Concave lens. concave lens. So as you see, convex lens, it's in both sides convex. So whether you are here or here, you're going to see it like convex. And here it means in both sides, from both sides, it is seen like what? Like concave. And I need you to remember what's the difference now between lenses and mirrors. Mirrors, what they do, they reflect the lights. What they do for mirrors, they reflect the rays, which is the light rays. It is reflected by mirrors. But for lenses, the light is not reflected, but it is refracted. What does mean refracted? That means it is bent. So that means here, as we explained here, for this one here now, as you see on the picture here, the light, when it is coming from this place to this mirror, it's going to be reflected back to the same side, of the what? Of the ray, where the ray did come from. So that means it is what? To that place. Okay, what about if we are talking about what? Okay, what about if we are talking about, we said, convex and concave lenses. For concave and convex lenses, the light rays are bent. That means they go through the lens to the other side, but they are bent either towards the principal axis or away of it. So here now, just we see here, so if we see this object now, we're going to see the difference between lenses and also what? Mirrors. So for the mirror, as you see here, for the mirror, it reflects the light. So the light now, the rays, when they are going towards the mirror here, they are reflected back to the same side of the mirror. So these ones are mirrors, as you see. These ones are mirrors, while these ones are what? Are lenses. So on mirrors, the light rays are reflected back to the same side of the rays themselves. While in lenses, as you see, the rays, when they move like this now, they go through the lens itself to the other side. They go to the right side, as you see. They continue, but they are either bent, as you see here, they go here, and they move, and they go to the other side. So we use lenses for the rays that we want them to pass through the lens and to go to the other side. Like glasses now, when we wear glasses, we have a problem on our side when we wear glasses. So that means these glasses are lenses, because the light that is reflected from object to our eyes will pass through the glasses into our eyes. So these ones lenses. But for mirrors, it's just reflected. So that means it will not pass to the other side. Okay, number two, another idea, which is a link between mirrors and lenses. The cases that we study for concave lens, we studied 6 cases. When it's gonna be real, when it's gonna be virtual, and where the positions of the image. These cases are also applied for convex lens. So convex lens, number one, it is convergent mirror here, and so this one is what? Convergent. As you see, it converge the rays into a point, and here the same, it converged into what? A point. So both concave mirror and convex lens, both of them are convergent pieces. While here, as you see, it diverges. So that means these lights now are diverged. So that means they go to further distance, more than they were in the distance between them. And also here the same, it diverge. Okay, cases now of concave mirror that we studied there, it's the same cases for what? For convex. And in general, the case that we studied for convex is going to be same case of what? Of concave. Okay, just how does that happen? How does that? This is just an example here. Look here now. If you see this image now, this one for convex what? For convex lens, right? For convex what? Lens. For this convex lens, as you see, when the object is at infinity, the image at the focal point. But if, on the other side, the focal point on the other side, because we said for lenses, the difference between lenses and mirrors, that for lenses, they go to the other side. We study the other side as well, while on that ones, it is reflected. And we studied only the extensions. We are studying the extensions of the other sides of the mirrors, the extensions of the rays, not the rays themselves. While here, we can study the rays themselves because they go to the other side. So here now, as you see, at infinity, at F. Here, if it is here beyond the F, you're gonna see the image that is between 2F and F. And here, if it is on 2F, the image will be at 2F. And when the object is between F and 2F, you're gonna see the object with the image beyond the 2F. So same cases of concave mirror, you apply them for convex lens. Same cases. And even the classification of real and virtual images, the same classification for concave mirrors, you apply it here. So that means here now, for this case, this image, we call it what? We call it real image. Okay, you're gonna say why, but it is on the other side. Okay, we said on the other side, so if we are talking about mirrors. But if we are talking about lenses, it's different. So for convex here, convex lens, all the cases are the same cases of concave mirror related to the classifications of the mirror and their cases. Okay, now just we understand now there is focal point for each one now. Okay, the focal point now, will it be positive in all of them? Okay, look here now, look at this picture back. If we go back to this picture now, as you see, these rays now, these rays themselves, they are reflected to the focal point. And these rays now, by themselves, they are reflected to the other points. But now, look here what happens. What happens for the convex mirror. When the ray comes like this towards the mirror, it is reflected away of the focal point. And now, if we study just the extension of the ray, so we put them as dash lines, you see, the extension will be to the F. And it's the same here. When the ray comes like this, it moves like this. Then if we make extension for the direction of its vector, we're gonna see that it moves like if it is moving from what? From the F. So in this case, the F is positive. And in this case, the F is positive, which is the focal point. But here, the focal point is negative. Because like if it is imaginary F, they are not going through it. So here now the same. So this one, F is what? Is negative. So remember that the focal point, so this one now is classified as convergent mirror, and this one is convergent what? Lens. So put that in mind. For convergent mirrors and lenses, the focal point, the focal length is positive. While if the piece is divergent, whether is it lens or mirror, the focal point, which is the focal length, will be what? Will be negative. And also the distance of image. What about the distance of the image? Just we have to remember and you have to understand that there are two or three main formulas we use them when we are solving what? Concave and convex mirrors and objects. What are they? One of them is 1 over F, and it is the most important. 1 over F equals 1 over di plus 1 over do. What is these ones? Here now, F is the focal length, the distance between the mirror and the F. This one is what? F. And di is the distance from the mirror to the image. So you write I here, distance, d, which is distance of image. Distance of image, that means from the mirror. And here it means distance of the what? Of the object. So this is now important formula. 1 over F equals 1 over di plus 1 over what? DO. So that means you have a distance for the image, and you have a distance for the object, and you have a distance for the focal point. And twice the distance of the focal point will be the distance to the center, which is the C. Okay, another one, which is magnification. So that means now, as we understand from the cases, in some cases, the image will be larger than the object. And in some cases, it can be smaller than the object. Okay, when we compare how small or how large is it, we compare it to the object. We compare it to the object itself. So that means the height of the image over the height of the object will give us the magnification, how many times is it compared to the object. So if the magnification is greater than 1, that means greater than the object itself. So the magnification becomes what? That means there is here, the image is larger than the object. So that means if the magnification, which is how image becomes bigger or smaller compared to the object. If the magnification is greater than 1, that means the image is greater than what? Than the object. Okay, if the image, for example, here, if the magnification is 2, that means the image now is twice the height of the object. If the magnification is 3, that means the image now is 3 times the height or the size of the object. And also here, the magnification, it can be also if we are, so here if we deal with the size of the image, if we deal with the distance of the image, so that means it's going to be di, distance of the image over distance of the object, and here is what? Negative. So m equals negative di over what? Over do. Okay, that means in some cases, the magnification will be positive and in some cases will be negative. So what we said about the focal point f, we said for convergence, whether is it mirror or lens, the f is positive. While for divergence, whether is it mirror or lens, the f will be negative. And keep that in mind. Okay, what about now the magnification m? Will it be positive or negative? Okay, the magnification now, if the image, we are talking about the image, if the image is virtual, the magnification will be positive. So that means now the magnification here, m, will be positive for virtual what? Images. And it will be negative for what? For real images. For real images, it will be what? Negative, the magnification. And it's related because in general, real images, they'll be inverted. They'll be inverted. So that means they are on the other side. So here the magnification will be negative. And related now to the distance, which is the di, distance of the image. So here we said f here will be positive for what? For convergence. For convergence, what? Whether is it device, whether is it mirror or lens. And f will be negative for what? For divergence piece, whether is it positive or negative. Now, when we are talking about the m now, m will be positive if the image is virtual, and will be negative if the image is what? Is real. Okay, what about di? Di is exactly the opposite of magnification. So that means di will be positive for what? For real images. For what? For real images. And it will be negative for what? For virtual. For what? For virtual images. So you understand now when the f is positive and when to be negative, so we deal with it. Then when we deal with these signs, when we apply these formulas, and the magnification, we understand now when it's going to be virtual and when it's going to be positive and when it's going to be negative. And I understand the di, which is the distance of the image, when it's going to be positive and when it will be negative. Okay, what about the do, the distance of the object? So the distance of the object, we deal with it like always positive. Always positive, regardless of where the position is. Okay, so now we understand the formulas. We understand the difference between concave and convex mirrors and lenses. We understand the difference between convex and concave, and we understand the difference between lenses as lenses and mirrors. Okay, now we're going to understand one of the applications now. Where do we apply these ones? By the way, microscopes, telescopes, glasses that we wear to see better. All these ones are applications of lenses and mirrors. All these ones. Also the car on the cars. For example, now when you have a car, you're gonna see there are mirrors there on the left and on the right side of the mirror. These types of mirrors are convex mirrors. And these convex mirrors, they're going to give you smaller images than how real the objects are. So that means behind you is a big picture, and you see it in the mirror of the car on the left and on the right side of the car. On the sides of the car, you're going to see the image is smaller. So for big image, so that means you get what is smaller. Even sometimes it's written on it as a note that images are smaller of how they are. So we have applications for these ones in real lives. So on the sides of the car, for shaving mirrors and for telescopes and for microscopes. And one of the main applications of these mirrors is for problems with sight, for people who can't see, for long distance, or people who can't see with what? With short or near distance. Okay, here now we have examples how it works. Okay, a normal people, normal person. Okay, to know just before, as a background, our eyes, it works like lens. Our eyes, it is mainly lens. It's not a mirror, it's lens. And what type of lens? It is convex lens. So our eyes is convex lens. This is now how our eyes, or the pupil of our eyes, exactly what? Convex. And with convex now, that means the rays that are coming now, the rays of light that are reflected from the object, when they go here, they are then what? They are converged. They are converged at a point. So that means this is now how our eyes work, as convex lenses. Okay, now normal people who they see normally, see things normally, this is how their eyes are. So when the rays now are coming now to their eyes, they are converged at a point here called retina. Called what? Retina. This retina now, then the retina here, when the image is converged at the retina, this image then is transformed or sent as a signal to mind. So the mind analyzes, our mind analyzes these images and understand what type of image is it, or what do we see? What do we see as a result of what? Of sending the picture from where, or the image from the retina by nerve signals. So this is now how normal people see. Okay, now we have two types of problems with people. We have farsightedness or nearsightedness. What is farsightedness? Farsightedness are the people that they can see far objects, but they can't see near objects. So we classify people based on what they can do. We classify people based on what they can do. So that means when we classify a person as far-sighted person, that means he can see the far objects. That means on the other side, he cannot see near objects. Okay, what is his problem? This person who is what? Far-sighted. The far-sighted, mainly his problem, this is his eye. So that means when the rays are coming to his eye, the image of this rays is converged here at this point, not on the retina, behind the retina. So this one now we said at the retina. But here now, as you see, the image is converged at the retina. That means he has a problem on the curvature of the lens of his eye. So that means it didn't converge them perfectly to be on the retina. So that means they are converged behind the retina. So how can we solve this problem now? To solve this problem now, we need to converge, we need to help the eye in order to converge the rays more in order to be converged on the retina. So in this case, what do we give them? We give them, as you see, what? Convex lens. So that means they wear convex lens. Now this convex lens now, as you see, it helps primary, it helps initially now to diverge what? To diverge the lights. Now these lights now, when they come to the eye, already they are diverged for a percentage. So this percentage now will help them now to have the image here converged at the retina. So that means when it is converged at the retina, it's gonna be sent as a nerve signal to mind, and it's gonna be what he's gonna understand what is in front of him or what he sees. So now, how we solve the problem of farsightedness people? By give them what glasses that they are convex lenses with the degree that is needed based on what's the distance here behind the retina the images are formed. Okay, now this is for farsighted people. Okay, what about nearsightedness problems? On nearsightedness problems here, this is now how is it? The image here, as you see, it is formed here before the retina. In front of the retina, not in the retina. So that means now, what the problem for this person now, he is classified as nearsighted person. That means he can see what is near, but he cannot see what is what far. Why? Because when he sees what is far, the image will be converged in front of the retina, not in the retina itself. So in this case, no nerve signals will be sent to the mind to analyze what he has seen. So how we solve this problem now? We give them what is called here now what concave lens. This one now, concave lens, as you understand, it diverges the light. It diverges what? The light. So the light now is, for some degree, it is what diverged. So we helped the eye with diverged rays. Now these diverged rays now, when the eye comes then as convex lens to converge them, they're gonna be converged at what? At the retina. And in this case, we say what? It is corrected. So you understand now, these ones now are main applications for understanding lenses and mirrors. So you understand fully lenses and mirrors, and you understand their applications. What we need to remember exactly is to understand the cases of lenses and mirrors, and you understand each case, what is the properties of image and other things. And questions that they are related will be solved in the quizzes.